Alright, so when I last worked on this thing, I was, I better shut off that shop radio before the copyright guys get me. Alright, so the last time I was working on this, I was playing around with these solenoid valves because I was curious about the flow that's coming through the torch and returning to the tank. It seems kind of weak. So what I did was I wired this up so that I could use a basically just a lamp cord, cheater cord to activate these solenoids without having to fire up the whole welder. And I noticed that when I fire up this one, it's got a much louder, crisper snap to it than this one does. So I'm wondering whether or not there's a problem. Now, it could be this one's just louder because this is the air one, and maybe because this one actually has water in there, that the water acts almost like a shock absorber and makes it sound like that. So I've got to try and verify that. And the other thing was I wasn't positive whether or not these 115 volt coils in these solenoid valves, and I am now confident that they are, because you can't really see much of what the sticker is on here. It's a 05-60 something, but this one's still intact, and it says it's a 05-601. Okay, if you plug that in to the internet search engine, Airco 05-601, this comes back as a valid Miller part number. Because again, remember, we're talking about that this was actually manufactured by Miller and sold under the name Airco. So this is actually a Miller valve. Furthermore, I was able to find that it appears that the modern, or the newest version of this valve part number is 035-601. So those of you guys who are trying to replace a bad valve, you're going to have a hell of a time finding any of these, but you might be able to find a 035-601. Let me double check that. All right, first, let me see if I can show you what kind of flow. This is now the return line that goes back to the tank. I've taken it off the tank on the cooler, and I'm going to just dump it into here, and I'm going to show you what kind of flow is coming out of here and why. Once you see it, you'll see why I think that there's something not quite right here. So first thing I got to do is I got to energize the pump. Alright, so of course nothing's coming out here, which I would expect because the solenoid is closed. Now I'm going to apply 115 volts to the solenoid. Okay, so that's pretty much it. So I might be wrong, but that just seems weaker than when quite a while ago I was working on this cooler, and I had it on the bench top, and I was dumping the water from the cooler, pumping it out into the sink, and I thought it had a lot more flow. All right, this is now the line coming right off the output of the pump. What you're seeing now for flow, the pump isn't even running. This is just gravity feed. Let's see if I can get the pump plugged in. See what I mean? That's a virtual geyser compared to, it's like a fire hose compared to what I'm getting on the return. So we got a major obstruction here somewhere. And now I have this hose disconnected, so the water is no longer inside that valve. So there shouldn't be any shock absorber effect of the water that would affect the solenoid operation. And listen to the difference in operation between the gas and the water. This is the water. This is the gas. So here's what I think's going on. I think inside this water solenoid, I think it's actually not moving up and down the way it should. And I wouldn't be surprised at all if there's corrosion inside here, because I think that the previous owner was running regular water, tap water, for a coolant. All right, so it just took a couple minutes to take this valve out. It's real simple. Once I disconnected the lines, there's only two screws that screw up through the bottom of this L-shaped bracket. The bracket's actually welded to this main bracket. So now that I get the whole valve out, I could take this over to the bench, which is a lot easier to work on. Well, turns out you can actually read it right here. This is a Norgren valve. So if I really wanted to, I could probably find another one of these. I just need a 120 volt Norgren solenoid valve. This has got a brass body, but I've actually seen these with stainless steel bodies too. With these size fittings, and I would reuse these fittings right here and thread them into the new one. But let me just, I'm gonna mark, because I don't think this valve is, I don't think there's any reason why the input and the output on this valve can't be switched, because I don't see anything marking or denoting which side of these is the input and which side is the output. So that being said, before this sticker completely falls off, I know that the one on the right here is the output. So I'm going to put an O right over here, and maybe on the bottom.
Yeah, a better Sharpie than that one.
Alright, so now, just for giggles, if I take this nut off, I think it actually allows you to remove the solenoid from the mechanical moving part of the valve. So I think I'll do that. So this is just the coil. So I guess like if this coil opened, the idea was that you'd be able to just replace this, and you could actually not have to even disturb the plumbing to do it. I wonder if these 1/4 inch screws will come out without snapping off. Yeah, that one was easy. Look at all this crap. Well, there's really not much to this. There's a little plunger, okay, that the electromagnetic field of the coil acts on. That's got a little, almost like rubber gasket at the end there, so that when the valve is closed, that rubber gasket seals on this little, what looks to be maybe a stainless steel seat down in there. This little tiny spring sits in here, so that when this is up inside here, that spring is what pushes this, keeps this pushed out to seal this. When the solenoid coil is energized, that pulls this up, which pulls that little rubber seal off of the seat so that water can flow. Now the interesting thing is there's not much travel here that this thing can do because of the way it's designed. And that is really small, so it's not exactly a big orifice to begin with. You can see how small that is, as opposed to, say, this one on this side. So interestingly enough, there's a large hole on the right there that goes right to this fitting here, which is the input. And then the water is going to get metered down quite a bit because this hole is so much smaller. So by design, it appears that this is going to reduce the flow. Well, I cleaned out that crud that was in there. Let me put this back together. I'm hoping this rubber seal will still reseal. Oh, here's confirmation for me that this is a 115 volt solenoid. It says right there, 115 volt, 60 CY, 60 cycles. There's even a part number for it, a 225-114-2. I wonder if that's actually still available. You know, it did look like when I first took that apart, there was a little chunk of some debris or something in the seat on that valve, and I'm wondering if that wasn't the problem. Of course, we'll test it in a moment with the water, but just for the heck of it right now, I just hooked it up again here, and now when I compare the two solenoids side by side again, as far as what they sound like when they close, they sound more identical. That's that nice crisp close of the air one. Now they both sound nice and loud when they're opening, so I'm wondering whether or not this is going to be solved. For starters, I'm just going to turn the pump on and let the valve closed, and we'll see if we have any leaks. There's air in the system. Actually, we don't have enough left in the tank. Alright, I gotta dump this back into the tank. Alright, let's try this again now that we've added fluid. Alright, no leaks. Let's open the solenoid. Appears to be the same pathetic flow. Yeah, no change. I wonder if I could have a blockage in the lines to the torch. Alright, what I just did was I disconnected this line right here that goes to the TIG torch, and I put this rubber hose, which the OD of this hose actually fits pretty tight up inside this connector, because I don't have a fitting that I can screw up into there. So I just push this up inside there, put this end into the jug, and turn the solenoid and the pump on, and I get pretty decent flow out of this, a lot better than what's coming in on the return line. So I think my obstruction is somewhere in the TIG torch itself, or maybe in this connector block. So I'm going to go after that next. Well, I figured the logical place to look for a blockage would be right here. I blow into this hose here, I can definitely feel quite a bit of resistance. So I want to see how this looks in here. If I disconnect this from here and I can blow through this hose easily, then I'll know it's not the lines going to the torch and that's just something in here. I have no idea what's inside there. I've been reading the comments on the episode that I uploaded, first episode where I started dealing with these connections and everything, and one of my viewers left a comment, and he mentioned the fact that these little cut lines that are on the nut right there, those are what indicate that those are the reverse thread. So that's a handy tip, so I appreciate that. So I know that to unscrew this, I have to turn it like I... Ah! Ow! Oh, that hurt. Ouch. Damn it. That smashed my thumb between the concrete floor and that wrench falling. It happens. It's still hard to blow through here. Of course, right now I'm probably blowing the water. I'm forcing the water out. Yeah, that seems unobstructed. Gonna be in my hose, torch lines to the torch itself. I find this interesting that I can take a thin probe like this cleaning tip, this cleaning rod for welding torch tips. I could take this, and this goes right in here, no problem, with barely any restriction. If I try and get this to go in on this end, it won't go in at all. As a matter of fact, even when I go down to quite a bit smaller size, which of course, like I just showed, no problem, no restriction at all. I try and go in here, goes in a little bit further, and then it's hitting something. It does not want to go past that point. And then I noticed the hose apparently goes over probably a brass barb, and then it's wire tied right there. But this section from like here to here, this section right here, feels almost like it's squashed down or something. It's actually kind of at an angle too. And I noticed when I was taking this apart that the hose actually was sitting like this up against this nut. So my theory is that what happened was, at some point somebody was using this torch when either the coolant system failed or the coolant system wasn't switched on, and that this melted partially from the heat that was building up at this block from the current going through it. And I think that it deformed this. I bet, and I tell you what, I'm so confident that I'm going to cut this, but I bet that where this seems to transition right here, I bet you if I cut this right here, well, unless this actually is a rod, unless this is actually a brass piece that goes all the way over here, no, I don't know. I don't know. It's bugging the heck out of me. I might be making a mistake, but I'm cutting it. Well, I've cut away the insulation here, or the outer sheathing, so I could get a better look at the anatomy of this thing. And it turns out the reason why I couldn't get anything to go into this is because it has to make a sharp turn right here and get into this trough. So this little trough is where the water's supposed to flow, because this cable isn't just, this wasn't just a hose. I totally forgot that it's going to have the wire in it. So now I've ruined this torch. Well, guys, went up and had supper, and then I was poking around on the internet, did a little bit of research, and I feel a little bit better about what I did here. Many of you probably, when you saw me cutting this, you probably cringed and thought, oh, he's destroying that torch. Well, I opened up this end of the torch, took the handle off here, and saw the way that the anatomy of this thing is. And I went upstairs and I did some research, and come to find out, it's not at all that uncommon for you to get a blockage in one of these lines, and oftentimes it's the line that is also the power lead. What can happen, matter of fact, there's a damaged spot right, almost feels like there's an issue right here. What can happen is if the torch, if you start welding and the coolant supply for some reason isn't on, like you forget to turn it on, what can actually happen is the hose can melt. And when the hose melts, it melts to the wire. And then what happens is you end up with either a partial or a total restriction. And then typically what will happen is the hose will completely fail and melt. But there's actually an area right here that feels like it may have melted, and who knows where else. So what I'm going to do is, this is actually replaceable. This right here, this is the connector that is the cable that has the wire inside the hose, as opposed to this small diameter one is the gas hose, and this larger diameter one that just hooks onto this tube is the well, it's the supply, because we know the return goes to the power block. So I'm just going to unscrew this here. But I try and blow into that cut off end there, and I'm not getting any flow, barely anything. So now with this unhooked, I'm going to go back to my ends here. So again, this is gas, no problem. This is the water supply line. Okay, so when I blow into this now, if I have a restriction inside the torch head, I'll know it. But if I can now blow into this and it seems like the flow is pretty good, then I know it's on the return line, which is the power cable lead, this one, which is what I suspect. Actually, that's not exactly easy. What if that hose has also got a restriction? Alright, so now when I blow into this fitting here, now that I get the water cleared out of it, I can hear air coming out the other end at the torch. And I mean, it's not real easy to blow into, but then again, this is a very, very small diameter hose. But this one, on the other hand, I put my mouth around this hose, try and blow down this tube, it feels much more restricted. There is a little bit of air leaking through, which would account for why I do get some return water. But it's a lot harder to blow through this one than this one. So I think I've got a blockage on this cable. Luckily, there are replacement cables available. So this torch is a genuine Heliarc TIG torch by ESAB. It's a model HW20. So I think this is comparable to like the TP20. Not sure, but anyways, it's an HW20. So I was able to go on the ESAB website because I looked at power cables for TIG torches like on eBay, and There's quite a few of them, and I wanted to make sure that some of the ones that I saw that looked like they were really good deals would fit this torch. And I was able to go to the ESAB website and pull up the HW20 torch family 300 amp torch. So this is a 300 amp torch. It's a 25-foot cables on it. It's got 25-foot cables on it. So to buy this complete assembly would be quite expensive. But as luck would have it, look at all the parts here. If I look at number 13, which is the power cable, there's two of them listed. There's the 12.5 foot, and then there's the 25 foot, which is what I have, and the part number is a 45V04. So I take that 45V04 and I go on eBay, and actually I just placed the order. Yeah, I love the eBay app, blah, 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 blah. No thanks. All right, so I put in 45V04. Let me do that again just to show you the first thing that I saw. The first thing that came up was this Profax 45V04 torch. They misspelled torch. Power cable, 25 foot. So it's by Weldcraft. It's brand new, $24. So I'm like, oh, well, this is before I knew this was a 45V04. I'm looking at the picture and I'm like, I'm not positive whether or not, and this end looks right, but I don't know if that's going to be right. So I looked up this number, and that's what kind of led me to the ESAB site, and then I ended up finding that 45V04 is actually an ESAB part number. So I'm like, oh, okay, I'm golden. So I was going to buy that one, but then just for the heck of it, I decided to search from low to high, and this is the cheapest one, but it's not the one I bought. And you can see this is a brand new one here. I'll show you what I bought. So I found this listing here. Remember, the other one was $23.95. So this one's $25.45. So it's $1.50 more. But what this is this one's somebody's got a new open box. It's kind of funny, the listing. It's confusing because what they've got is they've just got a bunch of welding stuff I guess they had laying around. They decided to put it all together. They have a Y3M Best Welds 41V32 water hose, 25 foot. That's what's in this box. And they've got a Thermocut 25 foot 45V04. That's in this box. And then they got a Tempel 350F. And I'm like, wait a minute. And the listing says everything in the picture is included. So what I just bought is I bought the power cable I need. I bought a water hose, which is a 25-footer, which I'm not sure it may or may not fit my torch. And this bag right here, which is a bag full of 350-degree Tempel sticks, which these sticks run about $12 or $14 a piece to buy them at the welding supply. So I don't know how many's in there. But I was like, well, yeah, the heck with it. I'll take a chance and see what this is all about. So I think I got a good deal there. We'll see when it comes in. So it looks like we'll wrap it up here. So we're going to have a bit of a delay before we get back to the drama of the Airco TIG welder.